So we've done so many lessons, 5 complete lessons on things about graphs. Now it's time for us to take control and make a graph ourselves. And for this, we're going to do everything at once. So here's a list of the things that you can find using the function and its derivatives. Hey, that's a lot of things. And none of that technically is even calculus, except maybe the continuity thing. So, there's a lot of information you already knew how to find from your algebra, pre-calc, geometry courses. What about the new stuff? Well, I bet you can find out where all those high and low points are. Some people say the maximums and minimums are kind of important. That's what optimization is all about, making things the best they can be. Also knowing where things are increasing and decreasing, really important, and it helps you draw the graph, doesn't it? And so do these. I had a finance professor tell me inflection points are even more important than the minimums and the maximums, aka the extrema. And concavity helps you really get the shape of the graph. Those are 2 things you can't even find on your graphing calculator. So these are calculus dependent. What we're going to try and do is take normal graphs or not so normal graphs and look at each one of these details and try and put together a full picture. Here's our first example, and probably the only one in this video. This example above my head will do. So what I want you to do is for each one of these, kind of go through a systematic way of checking all the stuff that you possibly can. For example, for the x and y intercepts here, to get a y-intercept, let x equal 0. So I know that I have a y-intercept at 0. To get the x-intercepts, I'm going to have to factor. Now, factoring might take a minute. You'll have to remember how to do it, but it's not that hard. And when I factor, I realize I have an x-intercept at 0 and I have one at 6. So when it comes to my x and y intercepts, I know that I have 2 points. Not bad, good start. I know 2 points on the graph. When it comes to the domain and range, this is a polynomial. The domain and range are going to be all real numbers. Let me state that again. The domain is going to be all real numbers. We might need to find an extreme value to know what the range is. We can come back to that. That's not as important. I'll say focus on the domain here. I can also tell you the in behavior. I forgot to write that down. That's something else that you can find just by knowing this is a positive 4th degree. I know both ends are going to be going up. So that helps me. I know the domain is all real numbers. I know both ends of the graph are going up. There's no asymptotes, and it is continuous. It's might be symmetric, but I'm not sure just yet. So let's move on. Okay, I admit it. I was feeling guilty. I did write this down as the domain, and I did say both ends go up. I'm showing you the limits don't exist. They're going to infinity. Here's the first derivative, and to get your increase and decreasing portions, as well as the extrema, go ahead and find the critical values. That means you're also going to have to factor. So when you factor, you can find those critical values. I see them at 0, 6, and 3. That's going to allow me to come up with a sign chart and figure out where this is increasing or decreasing. Please remember that if I'm trying to find where the slope's increasing or decreasing, I have to plug these numbers into the function that's going to tell me the slope. In other words, I must plug them in the first derivative to get the slopes. From that little step, that's going to let me know where my maximums and minimums are. That's really important. Think about what would be an extreme value, and then how do you get the y component? Once again, I want you thinking about what are you trying to find? If you want a y coordinate or a y value, you have to go to the original function, which always gives you the y value. Plug in these numbers to the original function. That will tell you exactly where that point is, x and y coordinate. Now that you found your y coordinates, let's go to the second derivative. Take that derivative, factor it. It turns out I can't factor that well. I had to use the quadratic formula, but I can still make a sign chart. And I don't really know the number for 3 plus or minus root 3, but I can estimate and put some numbers in. And this is going to allow me to find out where it's concave up or concave down, and let me find the inflection points. We'll finish this on the next video.